All right, today we're going to be graphing applications of linear equations. So before we get in today, as always, we are going to start with doing a quick review. And for this first, at the top problem, you can choose any method that you would like, but I want you to graph 2y equals negative x plus 8. Pause your video now and give it a shot. All right, answers up. So for this one, and you could have chose to do other methods, I chose to actually to graph this in slope-intercept form. So the first thing that I did was I obviously solved for y, because in order to use y equals mx plus b, it has to be in that form. Y equals mx plus b just simply means that y has to be alone on one side. In this equation, y is almost on one side alone, but it's being multiplied by 2. So the first step is going to be to go through and divide every piece of the other side by 2. And you're left with this equation right here. Now, and when we graph using slope-intercept form, what that tells us is the number that's in front of the x always represents my slope. So this right here is my rise over my run. And this guy right here is my y-intercept. That is kind of like the starting point. So I'm gonna go left to right, 0, up 4. Your graph should have looked like this. You should have first plotted this point right here. That was our y-intercept. And then it was a matter of applying our slope. Because if my slope is my rise over run, what this slope tells me, if it's negative 1 over 2, it basically tells me go down 1 and go right 2 every single time. Or you can reverse that. You could also say you could go up 1, back 2, and that would also work technically. All right, so that's all I did. From this point, I counted down 1, right 2, down 1, right 2, down 1, right 2. And I just repeated that process. And then all you had to do was connect your dots, graph your lines, away you go. Okay. Now, today we're going to be graphing applications. So we're going to be getting into some different word problems, but we're still graphing. We're still going to be graphing linear equations. So let's look at our first example. So example 1 says Tanya has saved $100 in a bank account. Then she gets a job working at Starbucks and earns $50 a week, which she decides to put her whole paycheck in the bank account to save it. The equation that models this situation is y equals 100 plus 50x, where y is how much is in the account, and x is the number of paychecks. So those pieces right there that I highlighted are probably the most important part of this, and the first sentence. All right. And this guy. There we go. For some reason that didn't highlight. Those pieces right there are really probably the most important things that we need to know. So for part A, the first question it asks us is what was the initial amount? And this really just means what is the amount of money that she started off with before she started really like saving from her job. And that's where the first sentence really comes into play. It literally says she has saved $100 in a bank account before getting the job. So what that tells us is the initial amount is just how much was saved before she starts adding to the account. In other examples, it might be you're starting with an amount and you're taking money out of the account, in which case it would be a little bit different. But the initial amount wouldn't change. It's how much you start with. Okay. Now, part B says what is the rate at which the account is increasing? So this one, just simply for the fact that it says she earns $50 a week. Now, we don't know how many weeks, but we don't need to. Right now, it's simply just what is the rate at which she's increasing? Well, it's going up $50 a week. So that right there is our rate. We would say $50 per week. All right. So in any given linear equation, you're going to notice that those pieces are in very specific spots in the equation. When we look at in terms of comparing it to like y equals mx plus b, it just means that the number in front of x is my slope, which is why we said rate. So basically what we're saying is in this problem, M is 50. And it says the initial amount is 100. The number that's with it, not with a variable, this right here is basically telling us what our y-intercept is. So we actually have our first point right now. When it says when no time has passed, how much money has been saved, well, we know that that's going to be 100. Now, to get our other points, you could either do one of two things. You could either go through, and for part C, you could go through and plug each of these numbers in to our equation up here, plug those in for X and simplify to solve for Y. Some students, if you want to go through and actually graph it and do using our slope, that also is fine. So that's actually what I was going to do. So part of what we're going to be doing, or actually let's go through and do the plugging in, because that actually might be a little bit easier. So after 1 week, how much is she going to have saved? Well, she has $100 plus the next 50 that she's going to be putting in the account. So she's going to really have 150. And really, every single time, she's going to be adding 50. That's kind of the trend. That's the whole point of the change. That is our slope. So that's how all of my y values are going to be changing in comparison to each other. So part 2 says if she's going to save $50 more, she's going to be at 200. And the trend continues, 250, 300, 350, 400. And that's as far as my table goes. So part C then, or excuse me, part D says now we're going to go ahead and graph all those points. So my first point, left to right 0, up 100 is going to be here. In this case, I'm sorry guys, just so you guys know, I'm not going to make you choose any scales for this. So if you guys want to write these numbers in, I'm always going to give those to you as well. But first point is 0, 100. Second point is going to be 1, 150. Third point with X value of 2 is 2, 200. And you guys are going to probably notice that there is a trend for those points. And there should be, ooh, that was exciting. Go away. But we're going to keep graphing those points. And away we go. Now, this is kind of a weird example. Whenever we have word problems, you're going to see that right now, I didn't give you any other quadrants. And I really want you to think about why that is. Like, why didn't I go back in time? Why didn't I say, well, what's happening at -1? Which usually when it comes to most word problems, and most of the problems that we dealt with in the past, we are able to choose negative X values because normally you can choose any X value you want. Now, there's a reason why, though, here that makes no sense. So if I think about it, could I plug in -1? Sure, but she didn't have this job a week ago, right? So when it comes to word problems, a lot of times when there's negative X values, we will not include those because it doesn't make sense. My line is not going to continue this way. Because that's like saying, well, what happens at -1? She would be at 50. In terms of the trend, yeah, but did she have the job a week ago? No, we don't know how much money she had in her account a week ago. So when it comes to the word problems, this is kind of an odd one where we aren't going to have an arrow on the left side because I'm starting at 0, 100, and then I'm going off into the distance. Now, when it comes to labeling, I did say this is going to be a point that you're going to get on the quiz. It's going to say label your axes. All right. So this pieces, it just means that tell me what these values are representing. Tell me what the x-axis is representing and tell me what the y-axis is representing. Well, what's in place of X? All of my X values are in the weeks column. And that is something that I didn't notate up here as well. If you look up here, it says Y is how much is in the account and X is the number of paychecks. So what do you know? Those are going to be your categories. We're going to have my x-axis is going to be the number of paychecks. Or if you would have said weeks, that's okay too. Technically, those are one and the same. And then my Y's, what did it tell me it was? It said Y's was how much is in the account. So you could say anything like total, I don't know, total dollar amount, total in account, anything along those lines, as long as you represent something on that line to represent those numbers. Now, part E, you already kind of answered. It says, what does the slope represent? Well, the slope is the number that's in front of X, and you already found it. It represents that you're increasing its $50 per week. Good job. Now, what does the 0.4300 represent? Well, all of these points represent the x coordinate is the number of paychecks, and the y coordinate is the total amount in the account. So what this means when I write what does the point represent, it just means tell me in a sentence. It just means after 4 weeks. Or paychecks. Like I said, both of those are kind of interchangeable. She will have saved $300. Okay. So a lot of this stuff is still just stuff that we've kind of done already. It's just we're adding in some more meaning to it. We're adding in units. We're adding in some different types of questions. So what I want you guys to do, I want you guys to pause, and I want you guys to give example 2 a try. Go. Whoops, sorry guys, I made a mistake. On this one, I forgot to give you guys the equation. So I'm gonna give that to you guys right now. This is something where we kind of switch some things around. But in the future, you'll be writing your own equation, but today you do not have to do that. So the equation is y equals 27 minus 3x. Where, just so you guys are aware, x is the, what is it? X is the number of pounds lost. Ooh. And y is the total weight lost. Or is the new weight of rocket. All right, guys. So now pause your video. Now give it a try. All right, let's go over some of these questions. So first and foremost, the first question says, what was the initial amount that Rocket weighed? Well, in the problem, it says he finds out that the cat starts at 27 pounds, which for those of you that don't know is a pretty heavy cat. Depends on the breed, but we're going to assume that for this cat that's a lot. So this cat is going to be put on a diet. So the rate at which Rocket is losing weight, this right here is just a fancy way again for saying what is your slope. So the plan is for the cat to be put on a diet that allows them to lose 3 pounds every month. So that right there is going to end up being your slope. For the second one, it says, okay, we're going to fill in the table. So if you filled in the table, it was really just a matter of plugging in each of these different values up in our equation up here and figuring out what y is equal to. You could also just use the fact that you knew what the first one was, and every month you're going to lose 3 more pounds. So if you stuck with that route, that's also another route you could have gone. But at the end of the day, the next step was to graph. Now for this one, if you stopped here, that's okay. I realize, again, I forgot to give you the scale. But either way, no matter what, you would start up at 27, and then you would plot each of your different points. So after 1 month, we were up at 24 pounds total. At 2 months, we were at 21. 2 months, we were at 21. 3, so on and so forth. Now, I realize some of you might be looking at this and hopefully you're saying, sorry, I don't see any arrows. And you're right, because for this graph, if it's a word problem, we can't go outside of the axes. Because if I go this way, you're saying the cat used to weigh more. Which could they have? Yeah, they might have. But again, it's a guess. And anything that's a guess, we usually just don't worry about. Anything that's a guess or doesn't make sense. If I draw an arrow the other way, you're saying I can keep losing weight, but all of the y values are now negative. Can you have a negative weight? No, not at all. So that's a case where that just doesn't make sense. So this is one where if you're, especially if I'm in quadrant 1 and it's a negative slope, we're not going to have arrows on a problem like this. Part E, we already kind of answered. It says, what does the slope represent? It just means that says, looks like it says eat. It's supposed to say the cat loses 3 pounds every month. And that's your slope. That's the change in every month that this cat is kind of going through. Now, could we stop after a certain number of months? Sure. Do we know what month to stop at? No. But the graph just represents kind of the trend of where the weight should go if they follow the right diet. And then part F says, what does the 0.221 represent? It just means if your X coordinates are the number of months and your Y coordinates is rocket's weight, then at 221 just represents after 2 months, rocket weighs 21 pounds. All right. If you would like, there is a You Try Now problem that you can go ahead and try if you're feeling good about it. If not, you can now start your homework for the day. All right, guys, have a fabulous day. I will talk to you soon.